Hi, in today's video I'm gonna talk about sandwich theorem, which is used to calculate the limits of the sequences. What is the sandwich theorem? So when we have three sequences and an is smaller or equal bn and bn is smaller or equal cn for all integers n greater than some index n, and if limit an where n is going to infinity and limit cn where n is going to infinity are both equal to L, then the limit bn where n is going to infinity is also equal to L. Now let's do some examples. Here we have to compute the following limit. We can calculate this limit using sandwich theorem. Firstly, we need to find the smaller or equal sequence. We can find it by taking the nth root of the biggest element, which is 2 to n. Then we have to find the bigger or equal sequence. We can find it by taking the biggest element and replace the others with it. And it is equal nth root of 3 multiplied by 2 to n. The next step is calculating the limits, so we start with the limit of the smaller sequence. It is equal to 2. And then we calculate the limit from the bigger sequence. Because we have a multiplication under the root, we can split it up to two roots, root of 3 multiplied by root of 2 to n. And because we have a limit of multiplication, we can also split it up to two limits. Limit of root of 3 multiplied by limit of 2 to n. We can calculate the limit of nth root of 3 using this formula. It says that if a is bigger than 0, then limit when n is going to infinity of nth root of a is always equal 1. Here our a is 3, so this limit is going to 1. The limit of nth root of 2 to n is equal to, so we have 1 multiplied by 2, which is equal to. So both of our limits are equal to 2, and that means that our main limit is also equal to 2. And the second example, we have to calculate the limit of this sequence. So we can also calculate it using sandwich theorem. First, we write our main sequence, and we are looking for smaller or equal and bigger or equal sequences. Firstly, we need to find the smaller or equal sequence. We can find it by replacing cosinus with 1 because it is the smallest value of cosinus. And to make sure that our sequence is smaller, we can also add the 100 to the denominator. Then we have to find the bigger or equal sequence. We can find it by replacing cosinus with 100, y 100, because then we are sure that our limit will be bigger because the biggest value of cosinus is 1. In the next step, we're calculating the limit, so let's start with the limit of the smaller sequence. It is equal to 2/3. And then we're calculating the limit of the bigger sequence. That is also equal to 2/3. So both of our limits are equal to 2/3, and that means that the limit of our main sequence is also equal to 2/3. That's all for today. Thank you for watching, and I keep my fingers crossed for you.